let's move on to the next video. In this, I'm going to show you the chemical treatment, all about the chemical treatment and what are the process are required and what are the chemicals we require to complete this process. So I'm going to share the screen and I will show you. In the chemical treatment, neutralization, oxidation reduction, and chemical precipitation. These three different techniques have been used. So for the neutralization means here, neutralization is an important process to maintain the treated water pH. Anywhere, if we are going to neutralize something, that means the importance of pH automatically will come. Neutralization only occur when you are increasing the pH or you are decreasing the pH. Industrial wastewater often contain constituent acidic or alkaline which need neutralization prior to discharge or treatment. As per the regulatory agencies, pH should be maintained in the range of 6 to 9 for the optimum growth of the microorganisms, because microorganisms are very sensitive to pH. If pH is increasing or decreasing, it will change the whole biological activities. Also, chemical reactions may change. Commonly used chemicals for acidic waste like lime, dolomite, ammonia, caustic soda or soda ash, and sulfuric soda ash for the acidic waste. But sulfuric acid and hydrochloric acid are used for the alkaline waste. See, these are the acids, that's why we are using to neutralize the alkaline waste. For the acidic waste, we are using something which is in the alkaline nature, that is lime, dolomite, ammonia or caustic soda. That is completely adjust the pH from high to low and low to high. Oxidation reduction. What will happen here? There is a process occur of oxidation and reduction in the as a chemical reaction. Something is compound is can be oxidized or it can be reduced. That means you're supplying the oxygen or you are removing the oxygen. If you're supplying the oxygen, that is called oxidation, and if you're removing the oxygen, that is called reduction. So chlorine, oxygen, sodium hypochlorite, potassium permanganate, calcium hypochloride, hydrogen peroxide are all the oxidant. That means if you are using these substances, that means you are oxidizing the compound. For the removal of heavy metals in wastewater treatment, these are the oxidants that we are using to remove all the heavy metals, because this is something like it's a work, these things have some complex nature when it react with the metals. That's the reason it will make chelants or complex compounds and can easily recover the heavy metals. Next is chemical precipitation. When you are going to precipitate something, that is something in the dissolved form, but you add some other chemicals which will help the dissolved chemicals to precipitate, and once the precipitate happens, that can easily able to separate out from the water. This is why we are using chemical precipitation method. In wastewater treatment, dissolved and suspended particles removed by chemical precipitation by altering the physical state and facilitate to settle the impurities to the bottom, which can be removed by sedimentation. In the next slide, I will show you the picture. The coagulation is the process used to remove solids from water by neutralizing the charges of the particles suspended in the water to form a gelatinous mass large enough to settle or be trapped in the filter. Inorganic, organic, or a combination of both coagulant types are typically used to treat the water for suspended solids removal. Coagulation is very important process. What will happen here is whatever the dissolved particles or whatever some lighter solid particles, some suspended particles that are not able to remove through the screening method, through the normal filtration method, then only we use this method for coagulation. What will happen when you are adding, suppose most commonly used coagulants are alum, lime, ferric chloride, ferric sulfate or ferrous sulfate. These are the chemicals we are using. Once it will go, what will happen? There is some charges. The particles which we want to remove, that means impurities, and the chemicals, both are having the different charges. What will happen? It's all about that how it can enhance the charges. Once it will, the charges, I'm sorry, in this Here I will try to explain you by neutralizing the charges of particles. It will neutralize. Suppose one impurity is having a positive charge, and this chemical, when it will go, it will neutralize that charge, and automatically when the charges around, there is a boundary of charges, will neutralize. That means there is no charges now. It will be neutral. So it will bind with the chemical. In this way, it will start binding process, and the next process will come as a flocculation process. I will show in the next slide and I will explain. Flocculation is the formation of small number of aggregates or flocks. Like this is like neutralizing the charge, then it will merge the all particles with the chemicals and then start slowly. Here this process is called neutral charge. There is no charge now. Here is a charge, negative charge. So once there is a charges removed, then easily we can settle that particles with the help of chemical, that is called flocculant. So this is all mechanical agitation or air agitation. We are mixing and we are giving force or pressure to do it more efficiently. This is how chemical precipitation works. Now, physiochemical treatment, what happened here also, we are introducing the air into the system to get more easily, we can able to remove the floatables. So in dissolved air flotation, air is intimately contacted with an aqueous stream. That is means water at high pressure dissolving the air. The pressure on the liquid is reduced through a back pressure valve, thereby releasing micron-sized bubble. That means introducing the so many air bubbles into the water that sweep suspended solids and oil. Already in the last slide, I have explained about the how flotation works, how oils particles can be separated, and when it becomes a layer of scum can be easily removed from the water. That is the same treatment. Chemical physical part will come into this picture and chemical part will come into this picture. Now next is the biological treatment. Aerobical biological treatment. Aerobic wastewater treatment is a biological process to remove dissolved organic contaminants. That also have explained BOD, COD, how we can able to remove it. And nitrogen, phosphorus, and presence of oxygen and bacteria. All these things can be easily removed through the biological treatment. Oxygen is mixed into the wastewater continuously by air blower or compressor. Whenever there is a oxygen required in the any biological process, that means it will give oxygen to the bacteria, and bacteria with the help of oxygen it will decay, it will eat the organic matter and convert into the organic matter into the normal waste. Waste activated sludge can be separated by various ways. Activated sludge process. In the biological part only, there is a now activated sludge process is there. That can be, one is the conventional activated sludge and next will be extended aeration. So conventional activated sludge means, here I can show you little more clear. Wastewater, it is a solid removal. Then it will go to the pre-treatment and remove. Then again that air has been applied here and it will go to the secondary clarifier. Then sand filtration method. Again, when whatever the sludge is coming, it will remove through the as a sludge treatment. Then finally it will come to the water, come to the disinfection, and the effluent water can be removed as a treated water. The conventional activated sludge system contains a tank for wastewater aeration followed by a, this is the aeration tank, and followed by a settler. Then there is a settler tank. We can call it as a clarifier, and a solid recycle line. The wastewater flows through under constant aeration in the presence of activated sludge and exist at the end of the tank after 4 to 6 hours of residence time. So whenever the presence of activated sludge will take to settle properly after 4 to 8 hours of residence time. The oxygen concentration in the reactor should be 0.5 to 2 milligram per liter. That means that is the concentration of oxygen which should be present in the activated sludge, where values over 2 milligram per liter are considered lost energy. Extended aeration. This is the modified form of conventional activated sludge process in which the production of excess sludge is minimized by oxidation and increased residence time through the larger size of the aeration tank. What will happen in the extended aeration means the area of the settling tank is larger, the time has to be increased, and the sludge formation has to be decreased. That is the only reason. If you want to reduce the sludge formation, excess sludge formation, we can increase the time and we can increase the area of the tank by supplying the oxygen. So it can easily more and more, it will degrade it. And this is another advantage is extended aeration system is minimum of sludge handling facility. You need not to handle so much. Same like in conventional activated sludge process, we are handling so many things. So the sludge in extended aeration effluent is very light and not non-degradable nature. That means it is not able to degrade very fast. So increasing the time, increasing the area, adding of oxygen can help to reduce the activated production of excess activated sludge. So next is the sequential batch reactor. What happened here? This here also happened aeration and sedimentation process, but in the activated sludge process, there are different zones and there are different tanks for the process. But in the sequential batch reactor means it is coming. This process happened through a series. That means it in the sequence form. That in the sequence form means aeration and sedimentation clarification are carried out in both the system. However, there is one important difference. In conventional plant, the process are carried out simultaneously in separation tank. But whereas in SBR operation, that is sequential batch reactor, the process are carried out sequentially in the same tank. That means there is no need to remove the sludge or adjust the level. As currently used, all SBR system have 5 steps. First is the fill, then react, where the air is reacting with the particles with the sludge, and settle, that is settling time, sedimentation and clarification, then draw, that means remove, that decant and idle, it will stay there. Like here I can show you a unique feature of SBR system is that there is no need for a written activated sludge system. But in the last one, in the previous one, we need to remove the activated sludge. Both aeration and settling occur in the same chamber. There was a difference in the chamber. No sludge is lost in the reaction step. That's the reason there is no lost in the sludge. And none has to be returned from the clarifier to maintain the sludge content in the aeration chamber. In this picture, we can see very clearly that excess sludge is a waste. It is here, and the sewage filling here. This is a decant part, and this is a settled part. And here, air is mixing, and it is reacting with the sludge. Next, we'll come with the trickling filter, biological air filters. This is also works very good at this for the same thing, but trickling filters work like it is filtering some water. Uh, it is in the form of a completely bed of high permeable medium to which microorganisms are attached and through which wastewater is percolated or trickled. It will move like that. The filter media usually consists of either rock or a variety of plastic packing material. Rock filter beds are usually circular and the liquid wastewater is distributed over the top of the bed by a rotatory distributor, and the wastewater is allowed to contact the media for a short time. The collected liquid is passed to a settling tank where the solids are separated from the treated wastewater. So this is the process where different type of material is using to filter that filter media is made of maybe plastic or maybe it is a rock. So through that the water is completely able to filter from each section, which is covering a very huge area actually. In this way the water is being filtered. In practice, both portion of the liquid collected in the under drain system or the settled effluent is recycled, usually to dilute the strength of the incoming wastewater and to maintain the biological slime layer in the moist condition. I'll show you in this picture. Here you can see this is all the sludge and this is the water which is coming through here and it is continuously rotating. The limitation of the trickling filter include relatively high incidence of clogging, the long rest period required and the relatively low loading that could be used. This is also used for the activated sludge process, but there are different uh, techniques that we are using to remove the activated sludge. So in the next video, we will cover all about the anaerobic biological treatment. Hope you have got some concepts how the activated sludge is being treated by different techniques, by different process, and uh, how much that wastewater treatment is difficult. So let's move on for the next video. But if you find some difficulty even in the concepts, you can write us on email or also you can take a one-to-one consultation. I'm always available to clarify your doubts, and also I hope that this is just a basic of all about the wastewater treatment methods and technologies we are using in treating the wastewater. So in this video I hope that it is little mixing of many process, but if you can watch two times, three times, it will be clear for you. So let's move on for the next video.